Okay, so at the end of video 1, I asked you to think about that equation, the equation that for hydrogen plus oxygen making water. Okay, so hydrogen, non-metal, 1 electron in its outer shell, actually a gas at room temperature, and hydrogen always goes around as a diatomic molecule. It goes around in a pair, okay? So hydrogen has the formula H2, alright? This is me working on step 1, correct formulae. Now, hopefully also you came up with, for oxygen, the fact that it is O2, alright? And then water is in fact H2O. Okay, these are really common formulae, these, and you have to know these. So I'm going to work very slightly differently to the way that I did up here. I used colour coding for my numbers, but what I'm going to do here is I'm going to work in little boxes, okay? So I'm going to say, here we are, my hydrogen is a molecule that consists of 2 hydrogen atoms. And my oxygen is a molecule that consists of 2 oxygen atoms. Okay, so this is all straightforward enough so far. Now my water is then a molecule that actually consists of 2 H's and an O. So in balancing, I'm then looking to see that I've got the same number of atoms on the left hand side of the arrow as I've got on the right hand side of the arrow. And at the moment, the fact is that I haven't. My hydrogens are okay, but my oxygens are not, because I've got 2 O's here and only 1 here. So I've got correct formulae. Is it balanced? Well, no, it's not. Okay, so I'm going to change big balancing numbers to make it work. That's the only thing that I can do. So, the only thing I can do here, because I need more oxygens over here, but the only thing I can do is to have another water. So if I put a 2 here, that's telling me that I have got 2 of these water molecules, HHO. Alright, 2 water molecules. So now, oxygens, 2 oxygens. But the problem I've got now is that I've got 4 hydrogens here and only 2 here. So hopefully you can see that in actual fact, if I put another hydrogen molecule in there, that's 2 separate hydrogen molecules, hence I have 2 H2s. So what this means is 2 molecules of hydrogen react with 1 molecule of oxygen to give me 2 molecules of water. And that is correct. That's the ratio that hydrogen and oxygen react in. If you're wanting to do some more YouTubing, you can have a look and just Google some examples of the reaction between hydrogen and oxygen, because actually this is an explosive reaction. I used to do this when I had a school playground that I could use right outside my classroom. That it was enormous, and my technician would fill a plastic bottle up for me with 2 parts hydrogen to 1 part oxygen, and then you'll go outside and set a lit splint underneath it, and the force of the reaction was so great that the bottle would shoot up in the air at absolute rate of knots. It's basically rocket fuel. Okay, right, so I'm going to have a look then at a slightly more complicated equation, and I'm going to look at the reaction between aluminium and oxygen. Okay, so I'm going to do aluminium plus oxygen. Now, hopefully we know what these things make. They make for us aluminium oxide. I've chosen this example because actually the formula for aluminium oxide is quite a difficult one to get right. So going through our first step, which is correct formulae, I'm just going to show you a way that you can do this. Aluminium is a metal, alright, aluminium therefore just has the formula Al. Okay, metals, it's only ever one atom that we write, so it's Al. Now we've already discussed oxygen, it's O2. Okay, diatomic, non-metal, goes around covalently bonded to itself. Which means that aluminium oxide, because it's made up of a metal and a non-metal, well, it is an ionic formula, or an ionic compound. So we have to think of the ionic formula. The classic mistake that people make is they just write AlO2. But actually that could not be more wrong, okay? We mustn't do that. So, the way that I teach people to write formulae for ionic compounds is to think about the ion that the aluminium is going to make. So I'm just working out here. This is rough working essentially, okay? If you look on your periodic table, you will see that aluminium is in group 3, and therefore it forms a 3+ ion. Okay, group 3, 3+. Calcium, group 2, 2+. Magnesium, group 2, 2+. Potassium, group 1, 1+. The charge on the ion is determined by the group it's in. And then oxygen. Now, if you look on the periodic table, oxygen is in group 6. That means it has 6 electrons in its outer shell. When it reacts, it wants 2 more, so it forms 2-. Okay? So, if I write down the 3 of the aluminium underneath the oxygen and the 2 from the charge of the oxygen underneath the aluminium, I call this swapping charges, okay? It's a quick way to get the right formula. Because actually what's happening is aluminium's losing 2 electrons. So what this tells me is I need 2 aluminiums. Now they're going to give away a total of 6 electrons. Each oxygen can pick up 1 electron. If I have 3 oxygens, they can pick up the total of 6. So it's like cross multiplying that you would do in maths to get the same denominator. Al2O3, that's my formula for aluminium oxide, okay? That method will work for whatever you're trying to do the formula of, okay? Just a little aside here, if I'm trying to do lithium oxide, lithium forms a 1+ ion, oxygen is a 2- ion. If I swap the charges, that tells me that lithium oxide is Li2O. Okay? So, there we go. There's just a little hack, alright? Which I quite like. Okay, so now I've got back to my formula. So, correct formulae. Question, is it balanced? Alright, I'm going to draw my boxes. Aluminium. Oxygen. Aluminium. Aluminium. Oxygen. 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 Right? Am I balanced? Well, no, clearly not. 1 aluminium, 2 aluminiums, 2 oxygens, 3. There. Not balanced. Not even nearly balanced. Now the thing is that I could put a 2 here and give myself another oxygen. But that's going to give me 4 oxygens. Okay. 4 is not very helpful because I've got 3. I cannot make this 3. Alright, I can't make this 3. I can't split this, alright? So actually what I'm going to do is I'm going to make this even bigger first. I'm going to put a 2 in here. That gives me a whole nother one of these. Aluminium, aluminium, O, O, O. Alright? But what I can now see is that actually I've got 6 oxygens. So actually, if I give myself another 2 oxygen molecules, so I have a total of 3 oxygen molecules, I've got 6 oxygens and 6 oxygens. So it works. I've got 4 aluminiums here. I need 4 aluminiums here. They're on their own. I need 4 boxes. What number do I put in front of the aluminium? I put 4. That is now balanced. Okay, it's a hard one, but it's now balanced. Some of you may be aware that actually you can have 2, 1.5 and 1. Actually, that's fine. All right. But at GCSE we don't tend to teach the halves. They're not that helpful. Whole numbers tend to be more useful. All right. But what I've got here, okay, is I've got a 4:3:2 ratio, and that's really important. You could write 8, 6 and 4. It would be in the same ratio, and that's what's important. That's what needs to stay. Okay, so I'm just going to go through a couple more now, which may or may not be easier for you, so you can skip over these if you think you've got the hang of it, but otherwise these might be helpful for you. Okay. Right, so I'm just going to think about the reaction between magnesium and oxygen. So magnesium plus oxygen. So I've not bothered to do the word equation. I'm going straight to the symbols here. Now I'm going to think about my magnesium oxide. This is an ionic compound. Magnesium is in group 2, forms a 2+ ion. Oxygen is in group 6, forms a 2- ion. Sorry, they're off you. If I put those 2 ions together, 2+ cancels out 2-. So therefore the formula of magnesium oxide is simply MgO. Okay, so look at my boxes. 1 magnesium, 2 oxygens, 1 MgO. Not balanced. Oxygens here that aren't here. I can have 2 of these. Draw it in. MgO. Oxygen's fine. Need 2 magnesiums. 2 magnesiums. Like that. Alright. Now, don't be fooled, okay, into trying to just put together formulae. Yeah, so if I do potassium and I react that with chlorine, okay, I'm going to get potassium chloride, but the classic mistake is to go KCl2, and it's not KCl2, it's KCl. How do I know that? Because I know that, little aside over here, potassium forms a 1+ ion, chloride forms a 1- ion. Plus and minus cancel each other out. It's 1 of each. K, Cl, Cl, K, Cl. Cl's not balanced. Need 2 of them. Gives me another KCl, which means I need 2 of these. Alright? So you get the idea, hopefully. If I do sodium and I react that with oxygen, okay, I'm going to get sodium oxide. So I'm going to think about my sodium oxide formula. Na forms a 1+ ion, oxygen forms a 2- ion. These charges are different, so if I swap the charges, I can see that I need 2 sodiums to 1 oxygen. The formula is Na2O. So important to get your formulae right. This is an equation that people get wrong all the time. It drives teachers mad. 1 sodium, 2 oxygens, and Na2O has 3 atoms in it, 2 sodiums and an oxygen. Okay, so my oxygens are not balanced. The only thing I can do is have another one of these. I can have 2 of them in here. Na, Na, O. Right. Oxygens sorted. 4 sodiums here, 1 here. Clearly I need another 3, which gives me a total of 4 sodiums. Okay, there you go. Some examples of how to balance equations. Hopefully that's been helpful for you. So there's a worksheet for you to do as well if you are doing this as a set lesson. If you're just watching it for some revision, then that's absolutely fine. I hope you enjoyed. Thank you very much.